So basically what we're going to do here for make an overfitting detection is to partition our data into training data, the portion of the data that we're going to use to fit the parameters of our model, and then the validation data we're going to use to evaluate or check if the model is generalizing well to the new data. Generalizing well, it means that it's learning meaningful patterns in the data rather than just fitting to noise, just being biased. So that's basically what we're going to do now. We're going to partition our data, and then we're going to train our model on the training portion of the data, and then we're going to evaluate our model. If the loss of the validation is much, much larger than the loss of the training data, then we have detected overfitting. So that's what I wanted to demonstrate here. Let's start by building our data set, our simulated data. I'm gonna include a little bit of noise, not so much noise as I did before. So we will not be able to detect so much noise in the training portion. The validation portion is what's gonna help us to detect the noise. So let's see how our simulated data looks like. So we basically have, well, this amount of noise is not that bad. It's actually better than what I was expecting. And let's now go ahead and split that data that we generated here into the training portion and validation portion. For doing that, you don't need to specify a lot of indexes, or you don't need to slice your data manually. You can basically just import the model selection submodule subpackage from the package called scikit-learn. That is the same package I mentioned in one of our first sections that has a very nice toolkit of all sorts of features and functions that you use to apply machine learning methods, including this model selection class here that has train and test split function. This train and test split function is gonna take our simulated X and Y, and given a test size ratio that or proportion that we provide, it's gonna split our data in the training set here and the validation set here. So we're gonna have one training portion for our X value and for Y value here and here, and we're gonna have a validation portion for X value and for our Y value. So let's also fix our random state to make this reproducible, and let's do this split. So we have splitted our data here, and now we can train on this part of the data and we can validate on this part of the data. We can also plot our train and validation data to see how it looks like. So here we have the blue data points as our trained portion of the data, and we have 20% of the data set that we split into validation portion of the data set. Usually you keep the larger portion for training so the model can learn the patterns in the data, and then you keep the smaller portion for validating your model. So let's create a simple model here. It's just gonna be a linear model as before, a linear neural network with one single neuron, no linear activation, simple with two trainable parameters. And let's prepare for training our model. First, we have to split both our training and validation data into batches, so it has the required format to be fed into our model. Now let's only fit the model to the trained data. Let's leave the validation data aside, so the model will never see the validation data during the training. So you can see the loss value is decreasing. It's converging to 0.0091. Let's take a look at how the data looks like. So we basically have kind of a linear model fit here to this noisy data. We also plot here the validation data as before. So we are just making predictions on the whole data. For now, we can basically see that the model is doing some sort of fit, but it has a little slope because we kind of have some noise here, but it's still not that bad. I would say we don't see that wobbling kind of overfitting here. What we can do now is to, for example, we can take that same data that we generated before. We can do the split again, but this time we can tweak the portion of the validation data set, what portion we want to use. And we can also add here, change the amount of the batch size that we want to use for a train and validation data. I would recommend to stick to 10 for now and see if that changes. And we're gonna build a model that is more complex, and then we're gonna feed the model to our data. So this part here, it's actually part of your quiz. So I'll let you go and complete this fix me parts. And in the quiz, you're gonna basically answer what you see in your results when you compare your model fit using this complex model versus the previous model fit that we did with a simple model. You'll be able to do this exercise to answer questions in the quiz.